Hi, everyone. Thanks for joining us. Our talk is called The Curricular Asset Warehouse at the University of Illinois, a Digital Archives Sustainability Case Study. Our speakers will be Karin Hodgin-Jones, Robyn Bianconi, Liam Moran, and me, Jimi Jones, all of us from the University of Illinois at Urbana-Champaign. First up is Robyn Bianconi.
Hello, I'm Robyn Bianconi, the Senior Instructional Resource Curator at the University of Illinois Center for Innovation in Teaching and Learning. And today I'm going to talk a bit about the history and structure of our media archive and our efforts to develop a sustainable and preservation and storage infrastructure. So the archives at CITL, we are the Instructional Media Resources team. This was originally a media unit formed in the College of Liberal Arts and Sciences, mainly to support foreign language and linguistics courses. This was mainly audio recordings. From there, our unit expanded to support more types of media and projects, and supporting educational content in particular has been a central focus for our group, which led us into getting involved in online course development and production as that became something that existed on campus. For the last 12 years, we've operated as a campus level unit tasked with supporting a wide range of teaching modalities, face-to-face, hybrid, fully online. And that is both as a production studio ourselves, as well as in collaboration with other campus media and IT units. So as far as our archives, the material we produce a large volume of media and related assets, both for educational projects, that is time-based course content, custom graphics and animation, pedagogical materials related to teaching, different kind of assessment and data, internal production notes, departmental records, and we also maintain an event recording component of our studio that does different kind of campus recordings for a wide range of projects. One thing that is kind of unique to our archives is how our media is reused and updated. This is primarily for our educational content, for media used in courses that is offered over multiple years with multiple instructors, and then in a variety of modalities. So whether that is in a face-to-face course with a hybrid component, in a fully online course, or integrated into different platforms. Massively open online courses through the Coursera platform are one significant example of this kind of integration, as well as things like building the material produced into things like e-texts and other formats. So within Instructional Media Resources is the Copyright and Content Management Services team, which handles this kind of archival work. This originated as a library science position about 10 years ago in one of our earlier iterations of our unit. And essentially, this was due to our project volume and production getting to such that we needed some higher level cataloging and workflows in place in order to manage what we're producing. So the idea of developing these kind of archival systems was to allow our production staff to manage this higher volume of projects, to offer our faculty and other clients more diverse use of their materials, and with a kind of longer term goal of making the media that we're producing more accessible within the university and to wider educational communities where that's appropriate. So that handles the kind of content management archival component of this team. Copyright is a feature for a few reasons that are somewhat unique to curricular assets and the kind of productions we're doing. So faculty who produce courses with us generally hold the sole IP to what are called traditional academic copyrightable works. So this is the materials that they're producing in order to teach their courses, whether that's face-to-face, online, or any kind of hybrid component. This is a fairly significant exception to the work for hire copyright rule that comes into play when you are creating content under the terms of employment. However, in some cases where the university is providing greater than usual resources to create course materials, there may be a component where the university holds a dual license. How this is determined is somewhat complex. So I will just say that one thing we need to be able to track as we are producing courses through our studio is to kind of keep track of what are higher and lower level areas of production, whether that is a lot of video work, custom graphics, depending on how much they're using of our services, in order to be able to document where the university may have this other component of licensing coming into place. And then the kind of third factor of copyright that we need to be able to track in our productions is when there are third-party materials going into a course production. So in face-to-face teaching, there is a very well-established educational fair use standard for what faculty are allowed to use outside of copyright restrictions in their courses. This exists for online teaching, but is somewhat more complex and changes based on the kind of format and where these materials are being delivered. So as we are working with faculty to produce video, to produce these materials, we need to be able to track what kind of third-party materials are going into a work in order to keep an eye on how this can be reused going forward. So those are the main copyright considerations. And yeah, really making our archival materials reusable and discoverable is the main element to this team. And the Curricular Asset Warehouse project is designed to support these efforts. So again, we are looking to allow our faculty and other clients to be able to access and distribute their materials, which is reducing reliance on third-party content used in teaching. We are giving colleges a fairly fine degree of control as to where they want to host and distribute their content, particularly between different platforms. And again, with the idea of making this content more accessible to the wider educational community where appropriate, while still maintaining the access needed in order to meet what we are offering to our clients. So that is what I'm going to talk about now. I will then be going into Jimi Jones, telling you a bit more about the CAW project and archiving within our production environment. Thanks so much.
Thank you, Robyn. So I want to talk very quickly about how we operate at CITL. Our archives most closely aligns with the profile of a production archives. So think like a television broadcast station. We produce a great deal of video every year, mostly to support courses, but we also produce events for campus as well. So invited speakers and our commencement and things like that. So we have challenges that align very much with a production archives. So our chief patrons are producers, the people who produce our content, who are reusing the content that we produce. We have to turn things around very quickly from our archival storage. We are dealing with constantly changing capture technology. So every time we upgrade our cameras, for example, we and the archives have to be prepared to deal with new encodings and formats. And we found over the years that there was not a good, affordable off-the-shelf repository technology for preserving and serving out the content that we keep. And we have many different kinds of file types. So for example, here is a course that we produced, and you see that we have, along with the time-based media, both raw and finished video, we have things like PowerPoint slides and Excel documents and text documents and so forth. Everything that would go into producing a class, for example. So, because we didn't have anything off the shelf, we've been developing what we are calling CAW, the Curricular Asset Warehouse. Again, the chief purpose of CAW is to process and serve our production materials, mostly but not exclusively time-based media, to our producers. And in order to be useful, CAW has to facilitate the cataloging, the description, and the discovery of CITL-produced course materials, time-based media, and so on. And one of the ways that this works best is if we have, we call an import wizard, or tools that allow our producers, who are closest to the projects and know most about them, to mark up the objects with metadata. This is to avoid a bottleneck, which would be me as an archivist, having to generate descriptive metadata for things that I was not involved in producing. We also have to comply with American copyright law some of the things that Robyn was talking about, like FERPA and the Teach Act, because we're dealing with educational materials. We serve three kinds of points of view. Production side of things, so discoverability, accessibility, and reusability of content. The archives point of view, because we are a land-grant institution and must steward the data into the future that we produce. And the instructor's point of view, our chief stakeholder, which is the instructor who develops with us classes and media content. Again, nothing off the shelf worked. We looked at a few solutions like Collective Access, Preservica, and DSpace, but all of these tools had a kind of traditional library repository structure, an ethic. And so we needed something that worked more with materials that are constantly flowing in and out of the repository, not winding up in the repository and living there long term without people reusing and editing the stuff. So we found that also production style tools like Axle AI and Kino, while useful, would not allow us to mark up collections with enough metadata to be useful long terms in an archival sense. So we looked at things that did bits and pieces of what we wanted, but nothing that did everything that we wanted. We also wanted to develop a repository that allowed us to have collection level records and asset level records and have them communicate with each other. So for every collection that's filled with objects, those objects would have asset level records that would describe the collection that they're a part of. And ultimately, our data flows from camera capture cards onto our spinning disk servers, where they are collaborated on with producers and then ultimately get written off to LTO tape, in our case LTO7, for ultimate kind of end of life, long-term storage. You see here in this graphic the flow of data from cameras, which would be on the far left, through our file server, through our streaming infrastructure, where we allow our producers to collaborate on edits with our stakeholders, again, usually instructors, all the way to my domain, which is the archives on the right and the LTO tape. And why do we use LTO? The chief reason is because it scales up very well. It keeps the data local. We found that Glacier and other kinds of cloud storage incur mounting rental costs for data and costs for retrieval of data that we didn't want to spend money on. And we found when we looked at numbers about a year or so ago that our LTO storage infrastructure system saved us about $7,000 a year over cloud storage. It also allows us to have local control over sensitive student information that we would not necessarily want a third party to store for us. With that, I'm going to turn it over to Liam Moran.
Thank you, Jimmy. In designing CAW, we were trying to minimize the resources needed for it, both the resources in terms of what equipment and expenses we need to actually run up and how much time our staff were spending on it. So like Jimmy was saying, the work of adding descriptive metadata didn't fall on an archivist, but on the video producers themselves. And so we wanted to minimize the amount of new work that our production staff had to do on top of their production work. That's their core function to create these descriptive records. So to that end, we use a lot of open source software. We didn't want to reinvent wheels where we didn't need to. And we tried to have everything using known specifications and standards instead of trying to create everything from scratch. So if there was something that already did the work that we wanted or that we needed to get done, we would use the existing tool or the existing standard. And eventually that means that it'll be easier for us to back out of this system if something else comes along that supports those standards or those production workflows. The intent was to minimize the amount of new work and to be as helpful, in fact, to the production staff as possible. So where a record can do work, we would want it to do that work. So we'll kind of get into that on the next slide. To the extent possible, we want catalog records to be mostly automated, their creation. So most of the information in a record about a piece of media in terms of like the number of fields, are things that you can automatically measure by inspecting the file and its metadata. So, what is the resolution? What is the duration? That sort of thing. So a media producer shouldn't have to type in those values. Those values should be automatically added by something other than a person typing. And what the person typing should be doing is what is uniquely possible for them to do, which is describing what happened in the video clip or the project that this record represents. We also found that cloud is an unsuitable storage solution for us, both because this is production storage where the files that editors are working on are sitting on the storage, and we don't want them making local copies on their computer to edit from. We want them to be using the kind of canonical copies that are in used in the shared storage. And so having it local and as fast as possible is a priority. Also, cloud storage tends to snowball. So you need more and more storage the more content that you're creating. And of course, we want to support discovery, good stewardship of the content in terms of who's able to access it, and then being able to reuse that old content that people are able to access. All right, so this slide is a little bit old, but SD ingest, or the way that we're automating or semi-automating the ingestion of asset records, is the key to everything. So we no longer shoot on tapes like we used to, where the record would describe an individual tape. Now we shoot onto solid state cards, so it's born digital on a solid state file system, and the shoot isn't one file. It's however many clips the producers choose to make it, and so the challenges are a little bit different from shooting on tape or on film. Again, there's automation that we use using these open source tools. Media Info is does a lot of the heavy lifting for us because it can create a PB Core instantiation document natively. That's one of the flags that you can pass it, so it'll scan a file and then export a PB Core XML file that has an instantiation record. And then essentially what our ingest tool does is it wraps that in a PB Core documentation asset record that includes the other metadata that doesn't fit into an instantiation record. And one of our intents was to kind of use the downtime that the producers have when they're offloading content. So really, like the original version of SD ingest, the idea came from a producer asking us, like, can you build me a utility that will copy the data from a SD card onto the file system in the right location, and then guarantee that it's bit for bit accurate to what's on the SD card? And the answer was yes. And we could also, do some of this stuff that we had wanted done with CAW. And so this is kind of like the opportunistic, finding benefits for the people that are, ultimately doing the actual work of creating the catalog records, and then making it as easy and convenient and helpful for them as possible. So originally that was the idea. It was a utility for offloading content from SD cards and onto the file server, but it evolved into more of a crawler, since a lot of the data that we have doesn't necessarily come from a SD card. So the video might have, some of the material is shot on camera. Some of it is recorded from a screen, and some of it was brought by the teacher themselves that we add in later in post. And also custom artwork and things like that we find that we need to make it add into the video to make the content make better sense for the students. All right, so the technologies that comprise CAW, for the most part, they're open source tools. So Media Info we already discussed. Adobe Premiere is a paid software, but it's kind of the industry standard video editing tool, and our university happens to have a site license for Creative Cloud. MongoDB is a database system that is open source. It's well chosen for this use because MongoDB is kind of like a document database. So it has a kind of schema agnostic search engine where you can change what kind of fields of data you're adding to a record on the fly without breaking anything. So if we decided 5 years from now that it would be really useful to have a certain field in the records, that wouldn't cause any problems other than the older documents wouldn't be searchable on that field. Shibboleth is what we use for identity management. That's a SAML-based single sign-on tool that a lot of universities have adapted. There's a lot of Python software in there, so web application has a front end that's built in Angular and a back end that's built using AIO HTTP. And then a lot of these kind of peripheral applications that do sort of the work behind the scenes, the crawlers and that sort of thing. And then the web application itself is a containerized application in Docker. I mentioned that Adobe Premiere is kind of the one proprietary software that we included in there, but it's the standard tool for the industry. And one of the things that we have found as a challenge. So we use media info to kind of create records, or at least seed records for original video files. We need we need a way to also create records for edited video files. So videos that are composed from smaller files. And the way that we were doing that is by exploiting the way that Adobe Premiere saves project files. So a project file is a gunzipped XML file. And so we can write software, and we did write software that can unzip that project file and then parse the XML. And then from that, we can extract provenance information. So we can tell which source video files that we have sitting on our server and that we presumably created asset records for is this edited video composed of, and also which pieces of art and that sort of thing is included in this that shows up in the video. And that provenance information is very useful for us for the copyright evaluation phase, because if a record for a piece of video or an image file says that it can't be used in certain contexts, then we can inherit that rule just from this provenance information into the edited file. And also, since we're trying to build CAW to be as useful for the producers as possible, we can also edit or create new Premiere project files that maybe have the video imported already, or whatever sorts of project management tasks the producers say would be helpful for them. Yeah, so another thing that we could do is that when we want to move a project or a collection of projects from one, hot storage, say, to tape or to a different server, we can automatically update all the references to files in the project as we move it. Another thing that we could do is to replace standard art elements. So at our university, the university logo changed a few years ago. And one way to, so if we wanted to update a project, we would update that artwork. We didn't kind of backfill intentionally, but whenever we would open up a new project, we could update the artwork. By being able to programmatically edit Premiere files, you would be able to kind of like standardize or normalize your production techniques and methods. And Karin will be speaking next.
Hi, I'm going to talk a little bit today about sustainability and CAW. So sustainability for the Curricular Asset Warehouse case study is looking primarily at environmental impact, places where you have a change in energy use, reusability of materials, changes to the device lifecycle expectations, and how it is that those things meet their end of life. Economics, certainly how it is that it cost impacts, or what it does cost to manage a system with economic efficiencies and energy efficiencies under environmentally beneficial conditions, and especially looking at the effect of cold storage, or the LTO tape storage that Jimi mentioned as part of that strategy. And then equity, as Liam, Robyn, and Jimi all pointed out, the whole point of CAW is that this will be open source tools, replicable, and geared in terms of understandability, findability, usability to learners of all levels. So making sure this is accessible by other archivists, other entities for their own kind of instruction and use. In order to have a fair assessment of CAW at the University of Illinois, I've also done a second case study with PBS Wisconsin at the University of Wisconsin-Madison. And so there are some kind of comparisons throughout my section of the presentation that look at the similarities and differences. Also a production archive, also a very similar workflow to that described by Jimi, and also a number of the same concerns in terms of how it is producers have access to live files for editing, how it is that they do long-term storage, how it is that they manage on-site control, and the purposes and reasons, as well as costs for these things. So similar conditions, economic impact, they reuse a number of materials and they extend device life cycles. They also use a large volume recycling system like the University of Illinois system uses. In terms of economics, they're working toward a resilient system that has the most economic efficiencies, while the University of Illinois' Center for Innovation in Teaching and Learning may have more restrictions on their funds. PBS Wisconsin, with a mandate for public service and public information sharing, has less of that same economic requirement to be cost effective in quite the same ways. And yet they are always seeking opportunities to have the most minimally invasive, lowest impact, and least costly opportunities. So very similar circumstances. And equity, their mission is community engagement, and they have a service mission for information sharing to the community. So really a lot of the environmental impacts have been driven by cost. CAW has engaged with device reuse and innovative procurement. This has been just kind of opportunistically the opportunity to get access to new devices and test some things out. But PBS Wisconsin found efficiency gains with reuse. With the Adobe CC transition to subscription model, so Adobe Creative Cloud replaced the previous Adobe Creative Suite, which was a standalone single install iteration of the Adobe tools, and it has been replaced with Adobe Creative Cloud, which is a subscription service that continually updates and has bug fixes for each of the different software platforms within the whole Creative Cloud suite. These have had some pretty strong impacts on both teams. CAW changed to a team-wide adoption of Windows machines in order to kind of manage what those impacts were. PBS Wisconsin found they needed to dedicate a specific set of machines to identical standards, and I'll talk about that a little bit more in a minute. And then another one of the big drivers is the University of Illinois Surplus Inventory System. This is a system that is governed in part by the Illinois Climate Action Plan of 2020. It is a governing kind of document for the University of Illinois system that is engaged with decreasing our carbon impact and having overall sustainability impacts in all of our systems across the university at Urbana-Champaign, but the university system. And so this is a mandate for reuse, this is an expectation of reuse, and the items that move into the inventory system are available for reuse, but also expected ideally to be reused. University of Wisconsin has a similar large-scale inventory system, but it's not quite as useful for things like electronics, small-scale computers, because the threshold for what is required to return to the reuse in the inventory system is a much higher dollar amount. It's about $5,000. The interface for their engaging their inventory system also is quite challenging. And so it's not as useful as a system, and yet reuse is a priority for PBS Wisconsin. So looking at CAW in particular, one of the experiments, one of the testing scenarios was looking at the efficiency of different, the energy cost in the sense of energy consumption of different types of rendering and video production tools. So they looked at, for example, gaming graphics cards to potentially improve render times, but found those systems required 500-watt power supplies, which increased the energy need, the energy demand. So then the team tested older Windows machines with quadriline graphics cards and discovered that they didn't in fact need the 500-watt power supplies, but more standard power supplies. And as a result, there's a dramatic reduction in that energy consumption and lowering what is required to run, replace, maintain towers and peripherals. The quadriline cards had comparable render speeds to the energy-intense gaming cards, but they were able to be used on devices that maybe were a second-tier reuse computer that came from surplus, or didn't have to be a brand new top-of-the-line production computer or tower. Additional drivers of sustainability, going back to subscription software impacts. So when that transition happened between Adobe Creative Suite and Adobe Creative Cloud, both of the teams found one of the things that had to happen was keeping everyone who's editing an identical project on the same version, doing version control with the software. And so CAW found one of the best ways to do that, because of access to similarity of machines, was to switch everyone to Windows machines, reassess the software version control and operating system update schedule. And they wound up moving away from at least one piece of software that was that had some challenges in terms of its rate of being updated. So the Adobe After Effects had a challenges in keeping open project files accessible after multiple version updates. And I'll come back to that in a second. PBS Wisconsin took a different track. They have 4 dedicated editing bays that the producers are expected to use, and they're kept at identical operating system, identical Adobe Creative Cloud versions. But then the production team who are working on other projects are able to use any computers that they want. They're expected to maintain a specific system specification, and they're individually responsible for managing their own updates to try to keep them the same as the editing bay standards. So about Creative Cloud, when Adobe Creative Cloud was introduced in 2013, but the CAW team already had the license for Creative Suite and kept that through 2015. In 2016, when they transitioned to Creative Cloud, they encountered first problems with After Effects software updates. Within 6 months to a year, an open, unfinished Adobe After Effects project file from older versions, they were no longer compatible with new versions of the software. And they found they were having some bottlenecks in production. And older After Effects projects were going to do things like put branding bugs and different kinds of graphics into post-production of video. So they wound up finding they had to, because of this challenge of the updating software, switch to other types of graphic software like Maya and other tools. The team moved away from After Effects for their own production as a service archive. They had a really unusual circumstance where there was a course that was still using an older version of After Effects as an example for the classwork. And so they kind of went through the process of what has to happen to actually maintain an open project file on a device that remains accessible. And they discovered that they needed to dedicate a remote access machine, a frozen in time operating system, and a standalone license for the 2016 After Effects version for the dedicated machine in order to be able to serve a class like that in the long term. And so this is an interesting kind of side effect of this, looking at for archives. This is a pretty big roadblock for artists and archives if you want to manage or access in the future unfinished Adobe After Effects or other subscription software files. Kind of an interesting aside. So facilitating reuse in the shared inventory, the University of Illinois purchase and inventory system requires that durable equipment purchased by campus move back into the surplus system. And as a result, because there are lots of amazing computer science, engineering, and other cutting edge science related, STEM related laboratories on campus, really high-end equipment can move into reuse for people who need a lower tier of intensity of use of those devices over time. Again, University of Wisconsin-Madison has a higher threshold for their inventoried items that normally wouldn't capture just tower computers or personal computers or peripherals like that, but there are a number of similarly advanced kind of STEM field research areas who have a number of computers that they make available for reuse and wind up being transitioning to PBS Wisconsin. They have used that for most of their in-house office computers. So reuse is a virtue in the shared inventory. It's always a virtue. Both institutions, you can transfer devices directly between departments, or you can go to surplus and collect something that's there for second or third tier reuse. Really sophisticated devices move through both of these inventory systems, and so there are a lot of excellent devices available for reuse. Currently, the CAW production team is using 2 to 3 year old computers. They have identical specifications. PBS Wisconsin General Office machines are in their second or third reuse, and other units on University of Wisconsin campus kind of casually shift these to their use over time when they have a collection of devices that are available to move into reuse. CAW maintains tiers of reuse, and many of the team members are actually using 8-year-old devices for kind of lower processing functions. In every way, both of these production archives are really improving on linear device life cycles with this reuse. But they also are a little bit limited in what they can do in terms of standards of recycling and reuse. The extended producer responsibility model says that anyone who produces new devices should be responsible for managing their waste, and so they should recover as much of this as possible. So it's meant to compel manufacturers to either design to dismantle, remanufacture, refurbish their devices, but also to recollect them at the end of life and consequently produce information sharing educational materials so that people know how to send things back for reuse. But this typically requires that you have a single purchase and a single return, which is a little difficult to do when you have a large-scale inventory system where things are meant to move into a reuse strategy. But contract recycling for a very large-scale institution like the University of Illinois or University of Wisconsin, they can capture a lot more types of devices, and they can contract directly for a recycler who will take in not just specific products and brands based on purchasing, but they can capture things that may even be much older. And so within any kind of reuse or loop for recycling, there often are kind of externalities, devices that are too old, devices that weren't manufactured by that company, reasons why a recycler may not take something back. But when you have this very large scale inventory system, you can put this otherwise not reusable equipment into recycling, and it extends the life cycle that any one device could possibly exist within. So with that, if they can take back 20 or 30-year-old machines, then they can certainly have computers last 8 or 9 years, move between 2 or 3 or 4 different users. The University of Wisconsin, as an example, has contracted Dynamic Lifecycle Innovations for their recycling, reclamation, and reuse since 2019 until 2023. And they feature first refurbishment. They put everything back into reuse if possible, remanufacture by dismantling anything that's designed to be dismantled, and then functional recycling of returning things to their raw materials and then putting them back into the production stream. And so it's a very effective method of capturing substantially more of the electronics after a long term of use. So the environmental benefits honestly have been driven mostly by cost and efficiency, the access to cheaper modular components to create, for example, a server array that fills the need of CAW, where they need a 24/7 access for the producers for active files, but it needs to be at a relatively small scale. The features of cost and that efficiency, the availability of devices to do this, made it possible for CAW to focus on that. PBS Wisconsin similarly manages a local server array, which is much larger, but they do manage it locally instead of outsourcing it to cloud service because they need to manage its scale, they need to manage access, their engineering team needs control over its growth, and as a result, they also spec'd out that the benefit is mostly cost to have this, but they also are able to access reusable components through their local community inventory system. So kind of back to the slide that Jimi showed, why LTO and not the cloud? Well, cloud storage is often opaque to the customer. It can have really heavy environmental impacts depending where it is that a data management center is stored or is located. The anthropologist Stephen Gonzalez Montserrat's ethnographic work looked at the environmental impacts of data storage and urges caution for potential customers because of those features of sustainability with data. He points out that the average data center uses 40% of its energy to cool servers, which can amount to almost half of the cost of a user renting storage space going just to cooling the items that are being stored. The US Department of Energy estimates that a typical data center uses between 10 and 50 times the energy per floor space of a typical commercial office building. And according to the Digital Decarbonization Project, up to 65% of data stored is dark data, which is incidental and will never be retrieved. And so when we are contracting cloud storage and you're not doing what CAW is doing, which is clearing off projects after a period of time and then only leaving immediately needed files available on the server array, it can dramatically decrease how much of that kind of dark data is there and increase that efficiency. It's also the case that most hyperscale data services do back up their very low use data with enterprise LTO themselves. And that is also in part due to the reasons that CAW does, air gapping of data, and also just the decreased amount of cost and storage. So in 2018, LTO tape had an estimated cost of 1/6 that of keeping the same amount of storage on disk. Projected improvements in LTO, it might double or triple that in the next 7 years. It has very fast write times, but one of the things about sustainability is LTO tape cassettes are non-toxic wastes. Many of the vendors of LTO actually have take-back programs where they will directly remanufacture and reuse the cassettes themselves and degauss and reuse tape when possible. And so it's actually not necessarily going through a full recycling process, but a remanufacture process, which would be more ideal in terms of sustainability. The hot to cold production to archival storage system creates really the greatest benefits in terms of how this archive is managing its energy use. The spinning disks are just for things that are active in like a 1 year or less timeline roughly. LTO is for completed projects and things that are low retrieval. PBS Wisconsin, they have servers available for most files, and LTO is pretty much just used for their backup of completed projects, but they aren't storing their backups also on spinning disk. And PBS Wisconsin did an analysis, even though they don't have quite the same cost restrictions that CAW does, that it only costs them about $18 per terabyte for LTO 7 tapes and hard drives. For 2 copies of all tapes, where it would cost them about $27 per terabyte for spinning disk arrays. And so it's primarily cost driving why they have chosen what is ultimately the more ecologically beneficial choice for their long-term storage and duplicative storage. So CAW and PBS Wisconsin have shown these efficiencies are mostly driven by cost. A lot of it has to do with the kind of potential of reuse and the benefits of reuse within these very large scale inventory systems that allow users to have reuse. With extended producer responsibility models, it kind of incentivizes shorter loops because the individual who purchased it is likely to return it at the end of a single use of life. State inventories are really an unexpected model to try to reproduce, but in the case that these large-scale inventory systems could be engaged to promote device reuse and cost sharing outside and beyond the institutions, this might be an opportunity for archives and others outside of just these closed university or state systems to begin to access relatively sophisticated devices that can go through multiple cycles of reuse before they would no longer be functional, extending the life cycles even further. Thank you very much for attending our talk.